back, Tigers. In this video segment, we're going to talk about a geometrical concept called sine, cosine, and tangent, when to use it and when not to use it. Now, in any given triangle, if I know two pieces of data, I can find out the third piece. Now, you're probably wondering what this weird, funny-looking word is behind me. Well, it's my way of remembering, as well as other math teachers' way of remembering sine, cosine, and tangent. Here's what it means. Sine is going to be opposite over hypotenuse. Hypotenuse. Cosine is going to be adjacent over hypotenuse. Adjacent over hypotenuse, and I'm going to show you what that means in just a second. And then the last one is tangent. And tangent, the easiest way to remember this is tangent is going to be opposite over adjacent. And that's basically what all three of these words mean. And in any given triangle, if you look at the triangle and you label what you have, then you decide which formula will you use. Will you use sine, opposite over hypotenuse? Will you use cosine, adjacent over hypotenuse? Or will you use tangent, opposite over adjacent? Now, in the next segment, I'm going to walk you through each one of these. I'm going to show you tangent first. Hi, welcome back, Tigers. In this segment, we're going to talk about tangent. Now, I've got this right angle on the board, and I've got a base of 10. I've got an angle of 35, and I'm trying to figure out how tall this is. Now, the first thing I would do in this situation is I would go through this word SOHCAHTOA and try and figure out, do I need sine, do I need cosine, or do I need tangent? Here's what I would do. I would label what I have, basically. This angle is very important because whatever it's pointing to, whatever side it's pointing to, that's going to be our opposite side. Now, the base is also going to be our adjacent side because it's adjacent to the angle. And then the last thing what I would do is just label this hypotenuse. Now, I don't really need to know what the hypotenuse is. It's not being asked of us. What it is being asked is what the opposite side is. So now I look at my formula. I go through this. Opposite, hypotenuse. Well, I have an opposite. I don't really care about the hypotenuse right now. Adjacent hypotenuse. Well, adjacent. I don't really care about the hypotenuse. And the last one, tangent, opposite, adjacent. And that's what they're asking us for right now. So here's how I would do this. I would set this up. Tangent of 35 degrees is equal to, my opposite is going to be my numerator of the fraction, and my denominator is going to be the adjacent. Now, as soon as I set this up as this formula, I've got tangent of 35 is equal to x over 10. I want to get rid of this denominator. And what you would do is you would multiply this side by 10. You would multiply this side by 10. And watch what happens. Now I've got tangent of 35 degrees times 10. And basically if I go here, 10 times x is 10x. Divided by 10 is basically 1x. So I'm just left with x. And what I need to do is take my calculator here. There's a couple of, it depends on what calculator you have, but there's always going to be some buttons that say sine, cosine, and tangent. Tangent is T-A-N. All I have to do is push tan. I put in my angle, which is 35. I'm going to multiply it by 10. And I'm going to get my answer. My answer is this, 7.002. Now it keeps going 0.75382. Most of the time we want you to round to the nearest hundredths. If I look at this, obviously 2 is less than 5, so I'm just going to round down. My final answer is It's approximately 7. Now, in the next segment, I'm going to show you what happens when you know the height, but you don't know the adjacent. And we're still going to work with tangent, so watch what we do. Hi, welcome back, Tigers. In this segment, we're going to talk about tangent, but in this situation, it's when we don't know the adjacent side or the base. Now, I've got this triangle, this right angle triangle. I've got an angle of 40 degrees. I know my opposite is going to be 6, and my adjacent, I don't know. Now, the opposite is always the angle. The opposite is always the side facing the angle. So this angle is actually pointing at the opposite side. Well, here's what we have to do. Now, we're going to set up this formula. Tangent of 40 is equal to opposite over adjacent. Okay? Our opposite is always going to be on top. Our adjacent is always going to be on the bottom of the fraction if we use tangent. Now, there's a couple of ways of doing this, and one of the easiest ways that I show students how to solve this type of problem is this. What I would do is, if I know the numerator, I'm going to take the numerator, I'm going to divide it by the angle. And that's it. If I knew the numerator, I'm going to bring the numerator down. I'm going to divide by the angle of tangent. So now I take my calculator. I'm going to go 6 divided by, make sure you push the button that says tangent. And your parentheses should open up, and I'll put 40 inside parentheses, and I'll push enter. And now I've got an answer approximately, and I'm going to make 2 ocean waves as opposed to an equal sign. The 2 little ocean waves mean approximately 7.15. Now, in the last segment, when we were talking about tangent, we didn't know the opposite. The numerator for that fraction was unknown. We had taken that denominator and multiplied it next to tan. Well, this time, we don't know the denominator, so we're going to divide the numerator by tan of 40. Okay? So when you're doing tangent, say to yourself, do I know the numerator or do I know the denominator? If you know the numerator, you're going to do division. If you know the denominator, you're going to do multiplication. Hopefully that helps you as you go through some geometry questions having to do with tangent. Hi, welcome back, Tigers. In this segment, we're going to talk about a geometrical concept called sine. Now, I have a right angle on the board right here. I've got an angle of 55 degrees. I don't know my opposite side, and my adjacent side I don't know either, but they really want me to solve for x in this situation. My hypotenuse is 40. Now, I'm going to go back to that word, SOHCAHTOA, and you're probably saying to yourself, what's that mean? Well, it's all of the formulas that I need. Sine is going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. And tangent is going to be opposite over adjacent. Now, as soon as I label my triangle and I kind of figure out what I have and what I don't have, here's what I need to do. The angle always points to the opposite side. If it's a right angle, if it's a 90-degree angle, I've got 55 degrees. It's going to point to the height of this triangle, which is going to be my opposite side. Now, my hypotenuse always looks at the right angle. So the right angle kind of points to it. That's the best way to remember what side is hypotenuse. Now, in this situation, we're going to do sine. We're going to do sine of 55 is equal to x over 40. Why is it x over 40? Well, if I go back to this word, it's opposite over hypotenuse. I've got my opposite side over my hypotenuse. Now, if you remember what we did with tangent, if we always knew the denominator, all we have to do is take the denominator and multiply it by the angle. And that's all it is. So here it is really quick. We're going to take sine of 55 degrees. Don't forget the degrees. Multiply it by 40 equals x. If I know the denominator, I'm going to multiply the denominator by the angle. I'm going to take my handy-dandy calculator here. We're going to do sine, parentheses will open up. I'll punch in my angle, 55, close parentheses, multiply it by 40, and I get an answer that's approximately this. Now, approximately means we make these little ocean waves, 32.7, and it goes 0.766. What I'm going to do is round that up to 0.77. And that's how big, that's how tall the triangle is. That's how much our opposite side is. It's about 32.77 based on this information. Now, in the next segment, I'm going to show you what happens if we know the opposite, but we don't know the hypotenuse. Hi, welcome back, Tigers. In this segment, we're going to talk about sine again, but this time I've got a little dilemma. Now, I've got this right angle on the board right here. I've got an angle, I've got an opposite side, I've got a hypotenuse. How did I know that this was the opposite side? Well, the angle always points to the opposite side. So here's 18, it's down there. It's pointing off to the height of the triangle. So I'm going to call that my opposite side. Now, I'm going to go back through my SOHCAHTOA, opposite over hypotenuse. Well, if we want to know how much the hypotenuse is in this situation, I'm going to use this formula. Here's how it looks. I'm going to take sine of 18. 18 is my angle. Is equal to opposite over hypotenuse. My opposite is 20. My hypotenuse is x. Now, if you remember what we did with tangent, and if you remember what I said, if we know the denominator, we would multiply. However, in this situation, we know the numerator. So we're going to do the opposite of multiplication. We're going to divide. What I'm going to do is I'm going to take my numerator and I'm going to divide by the sine of 18. And basically, here's what I get. Now, it's an approximation. Even though I wrote the equals, it's going to give us kind of what it's close to. Make sure when you push sine, the parentheses open up. You put your angle in. You close parentheses. You make it equal. And now, this is what it's going to be. I'm going to make those little ocean lines again, ocean waves. It's about 64.72. Now, like I said, if you go back to what we did with tangent, and you say to yourself, now wait a second, I know the numerator. I'm going to divide. If I knew the denominator, like in the last segment, what I would do is take the denominator, multiply it by the sine, the angle, and figure out what my answer is. Now, you've got to remember this little trick. Just remember, numerator, if I know it, divide. If I know my denominator, I'm going to multiply. Hopefully that helps you as you go through sine. Hopefully that helps you as you go through sine concepts and geometry. Hi, and welcome back, Tigers. In this segment, we're going to talk about cosine. Now, it's a geometrical concept that you're probably struggling with or having difficulty with. Well, let's see if we can help you out with it, okay? I go back to my famous words, SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, here's what I need to do. I've got this right angle on the board here. I've got an angle of 50 degrees. They want me to find out how big the base is, or the adjacent side. The hypotenuse is 36. Now, you're probably saying to yourself, wait a second, how did you know this was the adjacent? Well, if you remember what we did with sine and cosine, the angle always points to the opposite side. The 90-degree angle always points to the hypotenuse. Therefore, if this is my opposite, this is my hypotenuse, this has to be adjacent. And the best way of remembering this is this. Adjacent means next to. Is the base next to the angle? Well, yeah, it is. So that's a good way of remembering where my adjacent side is. Now, here's what I need to do. I'm this time going to use cosine. I'm going to take my angle of 50. I want to find out the adjacent side. So, is equal to x over my hypotenuse. Now, this is my adjacent over my hypotenuse. And if you go back to this word, there it is. Cosine is adjacent over hypotenuse. Now, if you go back to what we did with tangent and sine, you're going to realize, well, wait a second. I don't know the numerator, but I do know the denominator. Whenever I know the denominator, I'm going to multiply the angle by the denominator. And here's how it looks. Cosine of 50 times 36, oh, I forgot my degree, is equal to x. Now, I'm going to take my calculator, and this time, make sure you push the correct button. There are 3 of them. It depends on what calculator you use, but my cosine is right here. It's above the parentheses. Cosine of 50, close parentheses, times 36. Cosine of 50 times 36. I'm having a little calculator problems right now. And I get an answer of 23.14. Now, obviously, I've rounded this to the nearest hundredth. And basically, that's all I have to do. When I start doing sine, cosine, and tangent, the first thing I should always do is label what I have. And then I start going through this word, SOHCAHTOA, trying to figure out what exactly are they asking me for? Are they asking me for the adjacent? Are they asking me for the hypotenuse? Or are they asking me for the opposite? Now, in the last segment concerning cosine, I'm going to show you what happens if we know the adjacent, but we don't know the hypotenuse. Hi, welcome back, Tigers. In this last segment, we're going to talk about cosine and what happens if I know the adjacent, but I don't know the hypotenuse. So let's go through this. I've got this right angle. I've got an angle of 20 degrees. I've got a base of 8. I don't know what the hypotenuse is this time. I want to find out. So here's what I do. Now, you're probably saying to yourself, how do you know that's the adjacent side? Well, is the angle next to the given number. So they gave me the base as 8. Is the angle next to? Yes, it is. So it's my adjacent side. If you forgot, think to yourself, where would the opposite be? Where would the hypotenuse be? Okay? So here we go. Now I'm going to go through my SOHCAHTOA. I'm going to ask myself, which one do I need? Well, sine is opposite over hypotenuse. No, they don't want us to know this part. Cosine is adjacent over hypotenuse. That's what we need to do. So here we go. Ready? Cosine of 20 is equal to my adjacent over my hypotenuse. Now, if you go back to what we've done with sine and cosine and tangent, and you say to yourself, wait a second, I don't know the denominator this time, but I do know the numerator. Well, in this situation, if you know the numerator, you're going to take the numerator, you're going to divide by cosine of 20. And there it is. So I'm going to take my calculator this time. I'm going to go 8 divided by cosine of 20, close those parentheses, and I get an answer of this. It's approximately 8.51. Hopefully that helps you as you go through sine, cosine, and tangent. Remember, I knew the numerator, so I would divide. If I knew the denominator, I would multiply. Hopefully that helps you as you go through this geometry and sine, cosine, and tangent. And what I would just do, and I've told kids this in the past, whenever I see a problem that kind of looks like this, I would automatically write this word, SOHCAHTOA. and then go through all of my options. I'm going to show you a what-if problem, and I want you to decide. We'll walk you through it. Decide what you're going to need. Will you need sine, will you need cosine, or will you need tangent? Hi, welcome back, Tigers. In this situation, I've got this right angle behind me, and they want us to find out what x is and what y is. Now, in geometry, you're going to experience a couple of these triangles where we're trying to figure out how to solve for x and how to solve for y. There's a couple of things I would do first. First of all, I would write my funny-looking word, so, ka, toa. And basically, in case you forgot what that is, that stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, the next thing I would do is I would start labeling my triangle. Here's my angle. My angle here is 35, and I'm going to say to myself, what is it pointing to? What side is it pointing to? Well, it's pointing to the base. It's pointing to x. The angle that is given always points to the opposite side. Now, if you remember from any of the other clips, the 90-degree angle always points to the hypotenuse. So this is going to be my hypotenuse. It's a funny word to spell. Okay? And there it is. And then the last side, obviously, if I've got an opposite side and I've got a hypotenuse side, obviously, this side is going to be my adjacent. Now, as I start going through this, I start saying to myself, what do I need to do? Well, in order to solve for x, I need to go through my formula, sine, cosine, and tangent, and I need to decide which one it is. Now, they give me the angle. The opposite side is unknown. Okay? So let's go through this. Sine, opposite over hypotenuse. Well, I only know the opposite. I don't know the hypotenuse, so I can't do that. Cosine is adjacent over hypotenuse. Well, I want to concentrate on x right now. I don't really care about y. I'll get to y in just a second. So let's figure out what we can do to solve for x. Tangent is opposite over adjacent. I've got an opposite, I've got an adjacent, so tangent works. So here's how this works. Tangent of 35 is going to be x over my opposite over my adjacent. Now, that's a funny looking 15. Let's fix that, shall we? Now, what I need to do is, since I already know the denominator, I'm going to take the denominator, I'm going to multiply it by tangent of 35 degrees to find out how much x is. Now, it's going to be an approximation because we're kind of estimating here. So here we go. Tangent of 35, close parentheses, times 15 is equal to 10.503. Now I'm just going to round that to the nearest hundredth. It's going to be approximately 10.5 or 10 and 5/10. Now, there's a lot of things that I could do with this next part. And one of the things I'm going to do is I'm just going to keep what they give me. So they gave me 35, they gave me 15. Those are my constant values. Those are the values that I know. So here's what I need to do. In order to solve for y, when I started going through these letters, I kind of stopped here and I said, I don't really care about y. Well, now I do. So here it is. Cosine is adjacent over hypotenuse. So I'm going to take my angle. So I've got cosine of 35 degrees. My adjacent is 15. My hypotenuse is unknown. Now, unlike this situation where we don't know the numerator, if I don't know the numerator, I'm going to take the denominator and multiply it by the value. Well, in this case, I don't know the denominator. So the opposite of multiplication is going to be division. Here's what I'm going to do. I'm going to take 15. I'm going to divide by cosine of 35 degrees. I'm going to go back to my calculator, and I'm going to estimate this, well, with my calculator, round it to the nearest whole number, or in this case, the nearest hundredths. So I'm left with this approximately. It's 18.311, so I'm just going to leave it as 31. Okay? And I'm going to erase y, and I'm going to plug in my value, 18.31. And that's how you do it. Now, keep in mind, as we go through this, there's a couple of things I would have done first. I would have written down the word SOHCAHTOA first. And that would have given me all of my different formulas. Sine, opposite hypotenuse. Cosine, adjacent hypotenuse. Tangent, opposite adjacent. The next thing I did was label my triangle. Figure out what exactly sides I have, what sides were given, and what I would label those sides. They gave me the adjacent side. Remember, it's always to whatever angle they give you. And I needed to find out my opposite and my hypotenuse. Now, the last thing I would do is as soon as I start solving all of these problems, I say to myself, do I know the denominator? If I know the denominator, I'm going to multiply it by the angle. If I don't know my denominator, if I only know my numerator, I'm going to divide it out. So hopefully that helps you as you go through geometry with sine, cosine, and